So there's this little bonus question, which is probably one of the rougher ones at first if you look at it. It says, for all real x, f of x is x minus 3, and g of x is a polynomial of degree 2, such that g composed of f of x is 2x squared plus 3x minus 30. And I've got this little piece highlighted. So here's what I know. I know that g of x is at least x squared. That's what I know. All right, so I'm going to see what happens when I plug x minus 3 into x squared. X minus 3 squared, you write that thing twice, then you FOIL, is x squared minus 6x plus 9. Now, what I notice is I need a 2x squared. So I'm going to take this piece here and I'm going to double it and I'm going to see what I have. I'll get 2x squared minus 12x plus 18. Now, the next thing I noticed is that I need 3x. Now, what do I have? I have negative 12x plus 18. All right. So far, what I know about g of x is it's 2x squared. But when I have just 2x squared, I get this thing. So what I have to do is I have to add 15 x's. But remember, this is a composition function, okay? So what I'm going to do is I'm going to do 15 times x minus 3. Then I'm going to add it to that thing that I've got. This is 15x minus 45. So plus 15x minus 45. That gives me, I forgot my square there, 2x squared plus 3x, and I think minus 27. Look how close I am. I needed minus 30. All right, now I'm at 2x squared plus 15x. That's what I know about g of x. And if that's all I have is 2x squared plus 15x, this is what I get. So to go from negative 27 to negative 30, I've got to take away 3 more. That is g of x. That's what she is. So a lot happened there. I was kind of thinking outside the box, trying to recreate the original function. That's the only way I know to do it. I wish there was another easier way. You just kind of work with what they give you and take a look and see what you're missing and just keep thinking. So now that I have found g of x, I can find g of 3. I'm not going to do that, but you know full well how to find g of 3. Plug a 3 in. 2 times a 3 squared plus 15 times a 3 minus 3, and whatever that number cranks out to be, that's what you get. All right, last bonus. An airplane flying with a tailwind travels 1,400 miles in 5 hours. The return trip against the wind takes 7 hours, so you're flying against the wind is pushing you back. Assuming both speeds are constant, find the cruising speed of the plane and the speed of the wind respectively. So I've got this little guy right here, distance is rate times time. This can be manipulated so that time is distance over rate. That's probably what I'll use. Most of these problems that are worded like this is what you end up using. There's 2 times. There's the time it takes to fly there, and there's the time it takes to fly back. Time 1 is 5 hours. Time 2 is 7 hours. There's enough information here to write one equation. Time 1 plus time 2 is 12 hours, right? Because 5 plus 7 is 12. And both these trips are 1,400 miles. So I talk about time 1, it's going to be 1,400 miles over some rate of speed. Now, we're flying with the wind originally, so we have speed of the plane and the speed of the wind. So we have, we'll call R the speed of the plane and W the wind. R plus W, the rate of speed for the plane plus the wind that's pushing us. Time 2 took longer, but it's the same distance. But this time, however fast the plane is going, the wind is pushing it back. So we actually have to take off the wind speed. So there's my time 1 and time 2s. Now, what do I know about time 1 and time 2? I know that these two things have to add to 12. So the algebra on this one's going to get a little rough. There's a couple of you that will probably understand what's going on. A couple of you won't. Hopefully you will one day, because you know that's where you're supposed to get before the year's over. 1400 over r plus w plus 1400 over r minus w must be 12. Took my two times, add them together, add to equal 12. So I know that much. Now, we've been talking about eliminating fractions for a minute. So we're still going to use the same technique. The technique is to multiply everything by the LCD. The least common denominator here is r plus w times r minus w. And I don't know why I wrote 3. Erase that. That, boys and girls, is my LCD. So it goes here. And when it goes here, the r plus w's cancel. 1400 times r minus w. Plus, when it goes here, the r minus w's cancel. 1400 r plus w. And when it hits the 12, nothing cancels. So there's my equation. You're going to do some distributive property on the left-hand side. You're going to have 1400R minus 1400W plus 1400R minus 1400W. That worked out pretty nice. Wish I had a bigger board. Just don't have a big enough board here. So let me shrink some stuff up so I have more room. On the right-hand side, we have that 12 times r plus, we have 12 times r plus w times r minus w. And thankfully, that happens to be a difference 2 squares, so some stuff should disappear. I sure hope it does. If not, I'm going to have to go back to the drawing board on this one, which is a possibility. I think we'll be all right. When we FOIL these pieces together, we get r squared plus wr minus w squared. So that worked out nicely in my favor. That should be a plus. 2400R is equal to 12r squared minus 12w squared. I actually have a bit of a problem here in that I have two variables in a single equation. That is a huge problem. So I'm going to pause this video while I think about it for a second. I may not have approached this one correctly from the start, which is always a possibility. So let me pause it real quick, collect my thoughts, and I'll be right back. All right, so it took me a few seconds to figure out. I went back and I was glancing at something here. I have some numbers here. Time 1 is 5, times 2 is 7. So 5 must equal 1400 over r plus w. What I'm thinking of is if I can solve that thing for w, then I can replace whatever's here with r's, which is what I want. So that's what I'm going to do. So I'm going to r plus w both sides. It's going to give me 5r plus 5w equal to 1400. I am going to subtract 5r from both sides. 5w is 1400 minus 5r. I'm going to divide everything by 5. So w is, what, 280 minus r? This thing is going to be ugly. 2400R equals 12R squared. Take away 12. Probably should have done this earlier in the game here. Things would have been easier. Times 280 minus R. And that 280 minus R has to be squared, which means you're going to have to FOIL it out. I'm feeling pretty sluggish here. Something I'm going to do real quick just to make things easier. Everything up here is divisible by 12, so I'm going to divide that 12 out. That should be 200R equal to R squared minus what happens when I FOIL this thing out. So, aside from knowing what 280 times 280 is, it won't be too bad. I just don't know what 280 squared is off the top of my head, kids. 200R equals R squared minus 280 times 280 is 78,400. We're going to have a 280 times a negative R. That happens twice, so minus 560R, and then plus R squared. Let me shrink this up again. This problem takes some work, doesn't it? It really does. Now, something nice is happening here. On the right-hand side, we have R squared minus R squared. No R squared, so that's great. We have 200R equal to a negative 78,400 plus 560R after I distribute my negative sign. So here's what you can do from this point in time. You can solve for R, and once you have R, you can also figure out W by plugging in, okay? So I've taken it pretty far, and you guys can take the rest of it if you want the points. If not, don't. Don't be complaining to me, Mr. Milbrath, I needed 2 points on my ACT. I didn't get it. You should have tried harder, right? That's just the way it is, kids. So solve for R. You're now in a position where you can do that, and I don't have to baby step you anymore here. Plug back in to one of the time equations to get W, because that's what they want. They want the speed of the wind and the speed of the plane. So that's how you do it. And that was a tough little problem. I don't think there's any more bonus questions here, but there's the gist behind it. Hopefully you can figure it out. If not, keep studying.